So we are live now. Welcome to the February Defensio for the Synthetic Landscape Lab at the Institute of Urban Design at Innsbruck University. So today we will have two students that are part of our chair and are supervised by myself, Professor Claudia Pasquero, with Maria Kapsova. I would like first to introduce our guest and critic today. So we have Maria Ayolova. Maria, thanks for joining us. And Maria is an educator, designer, consultant, and community builder in New York City. She's an innovator in ecological design, smart city, and sustainable urban infrastructure. Maria is the leader of IOUD University in the Americas, where she directs learning, research, foresight, and innovation. She's also co-founder of Terraform One, Urban Research and Foresight Consulting Group. We have with us also Edward Cabey, architect, founder of Apparel Office in Barcelona, from which I think is connecting now. In parallel to practice, he teaches at the Institute of Advanced Architecture of Catalonia in Barcelona, the IAC, where he's a studio director, and he also directs a studio at the EPFL in Lausanne. Eduardo has lectured and run workshops in Mexico, Spain, Colombia, Iran, Morocco, Serbia, Italy, Belgium, Holland, and Singapore. Thanks, Ed, for joining. Always nice to see you. Then we have with us also Neil Leach. Neil Leach is professor at Tongji University, Florida International University, and EGS. And has also taught at IAA, where we met, Columbia, Cornell, Harvard, SciArc, and USC. He's an academic in the Academy of Europe and the recipient of two NASA Innovative Advanced Concept Fellowship to fund research into developing 3D printing technology for the Moon and Mars. He has published 40 books on architectural theory and digital design. Thanks, Neil, for joining. Here with us also Marco Poletto, who is our external examiner this year in Innsbruck. Marco is an architect, educator, and innovator. He is co-founder and director of Ecology Studio, as well as the Photosynthetica Consortium. His practice investigated the solving boundary between city and nature. He has designed and built biotechnological architecture, living installation, and biophilic protocols testing human interaction with non-human living systems. Marco has been Unit Master at IAA, visiting critic at Cornell University, Carnegie Mellon, the Barton School of Architecture, a research fellow at IOUD School of Architecture. He also a PhD from the MIT University in Melbourne, and is currently our external examiner and visiting lecturer in Innsbruck, as well as senior tutor at the IAC in Barcelona. So thanks for joining us. We have with us also Teresa Greskova, which is a PhD researcher in the lab as well. Maria, if you like to introduce the student and the brief, then we...
Yeah, thank you very much, everybody, for joining us. I would like to introduce two students who will be presenting their work today. Miroslav Ivan, and his project is focusing on the Central Pacific Ocean and the volcanic island Tarawa. And his master thesis is focusing on the solving issues of global warming, preserving the existing habitat and existing landscape of the island by the means of the synthetic fibers and synthetically grown biorock structure. The second presentation will be run by Dominique Wagner. Dominique's project is focusing on the territory of Lisbon in Portugal, and he is developing design proposal for sustainable aviation and proposing new infrastructure, new energy production system, and new means of transportation for this area, and touching, of course, all the areas of Europe. So guys, we're looking forward to see your projects. I see also that a lot of other students are joining us here on Zoom and for sure online. So we're glad to see everybody. And I think we can start with the project of Miro. Claudia, if the screen sharing is open, I think Miro could start with the presentation. Thank you.
Okay, so I think if everyone's ready, we can start. Okay, so hi everyone, my name is Miro and I'll be presenting my master thesis today. It's called Undesired Adaptation. It investigates an ecological synthetic fiber reef. For that, I would like to start with the introduction of the case study.
As we all know, climate change is real and it's already happening right now. Tarawa is a volcanic atoll in Central Pacific Ocean. The formation of such coral atoll took millions of years and has a typical shallow lagoon and steep drop on the outside. With Defensio being the most populated area of the region with the highest point just 2 meters above the sea level. According to its former president, Anot Tong, Tarawa has less than 30 years before it becomes uninhabitable, which makes it the perfect case study of ground zero of climate change. In order to address and solve these issues, I propose a synthetic fiber reef structure.
The structure is built with Biorock technology. Biorock is a structural material created by electrolysis of seawater. Through addition of low electrical current, much higher deposition rates than in nature can be achieved, specifically up to 20 millimeters a year. The material also has great structural strength, 3 times higher than Portland cement. This chemical reaction was invented already in the 1970s by German architect Wolf Hilberts. In order to better understand this process, physical experiments were undertaken, whereby each set of experiments examines a critical part of the reaction. The results were weighted and evaluated according to strength, volume, and porosity. This way, a pool with over 100 materials was produced, with each of them producing structurally and optically very different materials. Here you can see some of the samples produced. All of these were created in a time frame of 48 hours. For each function layer of the structure, a base material was chosen that best suits the function itself. This one shows the protection layer. The sample is enhanced with iron sulfates, as this mixture produced structurally the strongest sample. Natural habitat layer is enhanced with copper sulfates, as this sample achieved the most volume. And the industrial layer is enhanced with ammonium sulfates to provide the most flexibility. In the next step, the previously created physical Biorock materials are translated into synthetic landscapes of the site. This was done with the use of Cyclogan, an unpaired image-to-image machine learning algorithm, whereby models are trained according to source and target domain. In this case, those being the Biorock samples and the satellite image of the site. Each function layer was translated with its respective Biorock material. and these were then combined into synthetic landscapes of the area.
These were then combined into synthetic landscapes with each function layer mapped to its respective area. Two stages of the process were produced, with the second stage showing the development of the island once the land erosion stops.
These newly created synthetic landscapes are then translated into 3D. This is also done with the help of machine learning technology, whereby the most prolific features are being translated. The translation is done on the second stage of development, once the land erosion is stopped. Each function layer is translated with unique parameters of its respective Biorock material, creating a digital base for the structure. This way, the efficiency of the functions is further increased. And so we get to the reef. It is the bone structure for the Biorock to grow on. The efficiency of the functions is further enhanced through the synergy of densities and the individual qualities of Biorock material used. The fibers for the base structure are designed according to physical qualities of the Biorock material used for the function layers. This process creates the base structure for the reef. With the introduction of drop points, the structure growth is locally enhanced with further unique Biorock materials, specific for each programmatic function. This allows the structure to create optimal conditions for the nature to regenerate, but also provides optimized environment for the already existing local industries, such as fishing and oyster farming, which in turn generate further economical revenues for the inhabitants. The drop points are strategically placed according to the needs of the local inhabitants and also the needs of the ecosystem itself. At the same time, this growth enhancement transformation defines the form and function of the newly created ecosystem. Each function growth is enhanced with specific Biorock material that best suits the function at hand. The synthetic fiber reef also works as refraction-based breakwaters. This kind of breakwaters doesn't cause any land erosion as opposed to regular ones. And with the natural ecosystem regenerated, the structure also serves as natural diving park, creating yet another economic revenue for the inhabitants. And this is how I imagine the newly created ecosystem.
The synthetic fiber reef structure protects the land from erosion and floodings, creates perfect conditions for the nature to thrive in and generates economic revenue in tourism and industry, while at the same time being ecological and sustainable.
So thank you everyone for your attention.
Thank you, Mira,
Thanks,
for your presentation.
We can open to the comment.
Can I ask? I'm interested in this this 3D printing process. I've not come across it before, but can you do that in situ? I mean, how does it work, and how do the mineral deposits? How does that work with this system?
Sorry, can you repeat that? I didn't get that.
The 3D printing system you're using, can you do it in the water itself? I mean, how do you do this, and how do you deposit the minerals you were referring to?
Oh, well, the deposit. Oh, wait, excuse me. Sorry.
Miro, are you still with us? We lost Miro.
You got scared of Neil's question.
He had
Immediately
some
left.
Actually,
problems with
Miro,
connection.
the process happened just in the water.
Uh-huh.
And absorb calcium carbonate or phosphate from the water. So in theory, it also remove pollutant from the water, but it can happen just in situ, in water.
Yeah,
I'm
sorry, I'm back.
lab, which is what Miro did. Miro can explain better. So he simulated in the lab, but the main process is happening in the water. And if you simulate in the lab, you need to reproduce the sort of environment that you would have and the mineral that you will have in situ in the lab to test the growth. Miro, would you like to answer as well? You disappeared, so we started to answer on your behalf.
Yes, I'm sorry. Could you repeat the question for one last time? I'm sure I'll get it now.
Yeah, Claudia was actually responded. I was asking whether you could do it in the ocean, in the water itself, this process, and she responded to that. I mean, sorry, I have a personal interest in this because we have coral in Miami, and we actually had a session last week with Colin Ford of Coral Morphologic, and you should really have a look at his work because it's absolutely spectacular. This kind of hybrid marine biologist art work project. And anyway, and also one of our DDES students, Philippe Morel, has done a 3D printed coral reef as well. So this has been central to a lot of our debates that have been going on. So I didn't know about this process. And has anyone done anything yet? Has anyone built a reef this way?
Well, there was, as he said, there was a research project that started with the critical architect many years ago. And then in the lab, but also before in research with Marco and Maria in other institutions, we worked quite a lot on experimenting with biorock and growing it. In Barcelona, we tried in the river. But then we didn't develop it with the practice or in larger, more actualized research project. But yeah, it's basically applicable on site, and that was done at the beginning in the research that was carried on a few years ago. Yeah, exactly to regenerate. Originally was to regenerate coral effectively, but also to create a structure that could be architectural at this double way and will grow rather than be printed. The idea here is to understand how you control the growth in a way.
Because it needs a matrix, right? The growth doesn't happen anywhere. The great it happens on a support that is, I understand, metal, and that needs to be placed.
Yeah, this is similar to the support that you have at the beginning with coral nursery. So that's why at the beginning this support were cage and were studied as cage, because the coral nursery have a similar structure. But then you could grow or synthesize the mineral on top of them to create in a few years, create something that is as resistant as limestone sedimentation.
I have a few questions. So when you talked about the base material, you referred to it as fibers. Are they metal fibers? And then let me just give you my questions so you can answer them in any order. And also in terms of kind of the ratio of base material versus growth and the speed, because you said early on about 20 millimeters per year, but then the experiment that you showed us in the lab was over only 48 hours. So, so again, I want to understand what are the fibers, what is the ratio of base material versus growth over time?
Yeah, so for my experiments in lab, I used a much higher electrical power that would be suited for the nature itself, for a growth in the ocean, for an actual growth. And that way I could produce the growths at much higher rates that would be actually possible in the nature to not harm basically anyone or anything at the site.
But can you talk about the nature of the fibers and then the speed of growth?
So what do you mean exactly with the fibers?
What are the fibers made of?
Oh, the fibers are made of metals, as it's the bone structure for the biorock to grow on. So it needs to be metal, and once it's coated with biorock, it helps to prevent corrosion. So as long as it has its little electrical power, it can stay in the ocean indefinitely. And
what is the speed of growth of biorock in the ocean, not in a lab?
Well, according to Wolf Hilberts, the inventor, it's up to 20 millimeters a year. So, yeah.
I
think, yeah, I think you are able to produce the 2 centimeters a year easily.
I guess what would be interesting to me is to really explore the morphogenetic logic of this process, because it seems like do the wires remain there or something, or do they extracted? I mean, I think this is something that could have been explored in terms of trying to think what kind of growth systems you could have done. I could see their experiments showing you could do it, but I couldn't see any real, from what you showed, any real understanding of how you would build upon this as a kind of aggregation system of aggregation.
Well, I extracted the base for the fibers from the 3D cyclogan, from the 3D translation. I used that grid as as a digital base where I constructed the fibers on. And then I applied the enhanced growth algorithm onto it to simulate how we can control the points through the drop zones of further enhancements.
Yeah, I guess I was thinking not so much, but I mean the cyclogans. I don't know. They look nice, but trying to control them is very difficult. And I think to my mind, what's interesting, there are two kind of forces that need to be that could be addressed and brought into the logic. One is the kind of the ocean itself, the kind of tidal logics, and so on, all to do with the water itself and the dynamics of the water and where you would place this, but also the kind of how you would build up this deposit system, because there were some hints about that in the final drawing, but I couldn't quite see the exploration of the process of aggregating deposits and how you would therefore develop this kind of coral reef system.
Well, I imagine that as I did the experiments in the lab, you just need to put the materials into the water itself. So as long as the concentration around those metal fibers of the enhancement materials, in my case, I used sulfates, is high enough, the growth will be enhanced. And that's how we basically come to the structure.
Can you go back to the map of the island just to give us a sense of scale?
Yeah. I
think it was in the beginning probably, or
so I tried to apply it to the whole area.
I mean, what is the scale here? Is this in meters?
It's 1 to 500 is the grid.
Well, I mean, first of all, thank you for your presentation. I didn't say that. It was kind of really beautiful and poetic.
Thank you.
And then kind of that terraforming in the ocean on a massive scale. I have some familiarity with the process, and what I'm kind of questioning kind of the use of fiber. And this, I mean, we're talking these vast amounts, right? Of trying to, how many square kilometers are we looking here? I'm not sure, but it is a vast amount of base material that you'll need. So it's kind of that, kind of the question of design, right? I mean, how do you start? And what are these kind of the first places that you want to create? And then also, I mean, are we just going underwater, or are we creating higher grounds? Because we know the sea level rising will continue. So then, kind of, is there any, how should I say, priorities or hierarchy of this creating? And then is, as you said, can the metal fibers be augmented, right? I mean, we did a project probably over 10 years ago exploring a similar process for protecting the coast of Brooklyn in New York, where we're using retired naval ships and cutting them and submerging them in a bay, and again through covering them with this bio-rock material to stop the the erosion, but also it prevents you don't pollute, right? It stops the pollution once you have metal covered with bio-rock, and it's very conducive for oysters and other species. But we're talking, these are gigantic, if you imagine, naval battleships cut into gigantic sections. So you can be terraforming very fast. And here in this kind of a very lace-like approach, you need vast amounts of this base material. So, and the question is, again, if you can talk about how is this going to start, right? What are the phases? What is the hierarchy of creating these spaces?
We'll definitely need to start with the protection layer on the outside of the ADL, as the land erosion is the biggest problem of the inhabitants right now. The floodings and the changes of climate change are already applying to the island. So I would start with the breakwater structure, and then work myself inside to the island from there.
If we could just jump in 1 second, I think I found it quite interesting how Neil called the whole process kind of 3D printing at the sort of massive scale, if you want, right? And I think in a way that for me the most radical element of this project is the way you have attempted to deploy the machine learning algorithm to essentially program the printing, if we can call it like this, in bracket process at a very large scale. Because essentially the way you think of BioRock, as far as I'm understanding here, is really a process in which you slowly in time introduce frames or substructures in the water, and then by seeding let's say different areas of the sea with specific minerals, you kind of induce a project of natural mineral deposition, which is then enhanced by this. And so the question, of course, is when and where and how much, right? If the sea itself, if you want, with its complex set of interactions, is the main let's say driver behind this kind of a printing process, how do we know, how do we control such complexity? And so my understanding, which I found actually quite beautiful in its attempt, is that you say, okay, why don't we try to use the potential of machine learning to kind of channel, let's say, a non-human form of reasoning or intelligence, let's say, to drive this process, so that we can begin to create a framework for conversation with what may be, in this case, the intelligence of the sea, or the intelligence of the complex set of systems and subsystems that determine the actual microchemical composition of each of the different areas, which eventually will calcify in your new reef. So in a sense, I kind of like this kind of approach where all of a sudden you push a technique that is still relatively new, but in a way you apply it to a scale in which perhaps it can begin to reveal or to help us think about planning, let's say, synthetic landscapes from a completely different perspective. And, you know, of course, you talk about optimization a lot. It would be interesting to see what does it mean, the term optimization, from this new perspective that you have introduced through this experimentation with machine learning, because I suspect that's where the conversation can also become very interesting. What kind of optimization we are now talking about? Is it the one that we have inherited, let's say, from modernity and a certain kind of algorithmic paradigm, or are we now kind of introducing a new model of optimization based on this form of intelligence that perhaps we can connect more directly with the intelligence we find in ecosystems like the one you are working with? So I think that's where I think the project really becomes speculative in a good way, in a very potentially exciting way. Of course, I also like your little material samples. I think I would have liked to see a little bit more illustration of how you actually made them, because that would have helped kind of envisioning what it would be like in the real world, perhaps through that process. I mean, we get to see the final result, which is great, but you know, seeing how they came about, how they grew, maybe a little time lapse or something like that would have been quite fascinating as well, to help us imagining how that would translate into this vast scale of yours, and perhaps also to help us imagine what would happen in the next 30 years, which are, let's say, the sort of a hypothetical time frame to save this island. But you know, I think I think in particularly in that element of the application of machine learning and the logic to the landscape, it's a really exciting, and potentially for me there is material for pushing it forward in in a PhD or another form of research, because there are serious elements of research here that can be further developed.
Marco, can I jump in? Because I have to say, I don't know what you mean by machine learning, because it was not explained in the presentation. It was mentioned, but to me, what I lack is elements of understanding how the planning occurs, because I understand that it's generated by an algorithm, but I don't know what this algorithm reacts to. That's a question for Miro, actually.
Miro, do you want to answer?
Yeah. So I basically I took the Biorock landscapes and translated them into 3D. And I tried to take
landscapes? The Biorock landscape that you created?
That I created, yeah. That I in the first step I applied the Biorock I created onto the site.
How? That's my question.
With the machine learning technology with CycleGAN. So I translated the physical Biorock model onto the site in a, let's say, how do you say the word? Like a digital kind of way.
And is that better than a manual kind of way? Or how is that better than a manual kind of way?
Well, it allowed me to take the Biorock I had, the physical materials I created in the experiments, and apply them onto the site in a manner where you can take the information with you. You kind of still, as you take a look at the physical Biorock model, and then that's the image on the left top corner, and the one in the middle, you can still see the information taken with it.
But for me, it's difficult to follow you here, because what you're...
I think this goes, some of the projects have this type of investigation. We started to introduce machine learning, and I have an interest in correlation and pattern, as you know. So most of the work, or large part of the work that exists at the moment with application of CycleGAN often work with glitches and disruption, while we are trying to apply it in a different way, in which we try to recognize patterns that are similar at different scales, so that we transfer information from biological computer, mineral computing, to the territorial scale. So that's the type of experimentation that the students have been doing at different scale. Is a new type of experimentation that we have been introducing in the last 6 to 7 months.
But I guess for me, the question or
this sync between pattern is what we are looking for, and in this case is this translation between the observation of how Biorock growth in different manner with different stimuli, and how this could be translated at the territorial scale. Then how Miro thinks this is more or less successful in his project, maybe Miro should expand that.
Yeah, maybe if I can add just a few also notes on the explaining these points. So basically, Miro, if you can open some pages where you're investigating the material, like the Biorock material, no, that Miro was testing different sets of the material and then came to the conclusion which steps are giving the best results. For example, performing the best structurally, another one giving the like the richest morphology, or I don't remember which are other conclusions that he made. No? And then he was concluding like with the different types of the Biorock that he developed, and starting to associate these types of the Biorock with the substructure that he is recreating with the different densities. So programming different functions with the different types of Biorock. So for that reason,
what type of functions would they be?
So one of them is protecting, right? Another one creating the, Miro, maybe you can take my words and continue. So basically, just I wanted to say that, maybe in a presentation that was not really described really precisely, that maybe Miro, you can talk about a bit this deeper, because that was the logic. Of course, it's questionable if it's fully successful, readable, and actually suggests as the development of the project. So, and only after Miro was you explaining about the 3D cycle gun, that just was the second step. So Miro, if you can follow.
Oh yeah, so here are some of the functions I imagine. For instance, like oyster farms, fish farms, coral reef restorations, and those would be enhanced by those biorocks created in the experiments before. And so for each function, we then have one biorock material. We use that one for that particular function according its physical qualities I examined in the experiments. As for instance, for the oyster farms, I used a material that that was greatly enhanced in growth, as it should enhance the growth of the oysters. And same for the
I think what we're struggling with.
Excuse me?
I'm sorry, I didn't mean to interrupt you.
Okay, all right.
Can you hear me now?
Yes.
Okay. I think what we're struggling with is there's just something, there are stages missing from your story that you're telling us, right? You moved us from the lab experiment to this vast landscape that you created. And then so even the narrative is missing of what happens in between. I mean, I'm trying to imagine if I'm going to do this oyster farm. I mean, do I have like nets of this material that I'm going to throw in the sea, and then that will become this reef where oysters will grow, and I'll be like, seeding it with oysters within a couple of years. I mean, what happens, right? What is even if it's like a narrative of how this is going to.
Yes, this is also a bit what I struggled with, because I think the research is impressive, and I find this, from my opinion, on a small scale, I'm really convinced. No, I find it incredibly interesting, the process you're working with. I find it incredibly interesting that it's self-forming, incredibly interesting the fact that it has really high structural strength, and also that it develops over time with a certain level of control, no? and that it can attract marine life. So I think it's extremely cool, actually, and the fact that you can do this yourself in the lab, that you've been working through that, I think also is a great part of the work. When it comes to the narrative, I agree with Maria. You didn't tell us why you want to save this island. No, you mentioned the fact that that it's going to disappear, and that you want to save it. But for me, there is something missing. Maybe it's obvious that we have to save land. I'm not sure. Maybe it's for the population, but maybe the population actually needs to move somewhere else to be able to have other conditions. That's kind of a debate, I think, that we are not going into here. But I think I would have needed to be introduced to that population to understand who lives there. And I understand their activities are fishing and oyster farming. You mentioned it very, very shortly in the presentation, and now we're extending a little bit on it, because eventually what you're placing here, I'm wondering whether, is it a geoengineering project, which is about preserving an ecosystem, or is it about working with a population so that it can continue to have its activity, or is it both? There, I haven't, from what I understand in your presentation, it's mainly an engineering problem, because you're mainly working on the ground, and yes, you are developing potential fisheries, and I imagine maybe you actually, because I can feel that there are sometimes some ties to the local population, but in my opinion, they are kind of shy. and I'm wondering how you can reinforce it. No? I was wondering whether your structure needs to remain underwater because of its structural, kind of astonishing structural capacity. This system could also work as potentially as a foundation system for other forms of inhabitation that could be human. That could be also potentially agricultural in the sea. I like how you flirt somehow with the level of the sea. No, in your section we have the kind of horizon line or the sea level, and then you're coming until very close to the water surface, which probably is problematic in the case of navigation, of boats, of fishing. But then I think has potentially a very nice relationship to again how people can inhabit it. And then the last point is I'm wondering, I'm very interested in the generation of the master plan, if we can call it like that. How do you decide to what density in what form? And that's what I was trying to understand before when Marco was making his comments, because I understand really well your system on a small scale, on the scale of the 20 millimeters, and I really like it. And on the larger scale, because eventually, as Maria said, it's a vast...
I think this comes from the training of the algorithm. And I don't think that the algorithm was trained to save the island. I think maybe we should ask to the, if we could, maybe we should ask to your friend machine learning algorithm now trained as a biorock generator, if it really thinks that we should save the island or not. Because somehow I think that your narrative, it's a little bit shifted from what you have actually done, no? And in a sense, it's understandable completely. On the other sense, I think that it would be fascinating to try and resist a little bit that kind of a narrative that we all sort of hear several times, and understand whether kind of exploring and declaring and defining more literally what you have actually done through your algorithm may reveal another perspective that may be valuable, maybe even more so, in terms of what could we do with such scenarios that, you know, obviously are kind of significant to the challenges we are facing, but perhaps are also significant to offer new perspectives with regards to these challenges. No?
Yeah, can I just chip in? I think that, I mean, intelligence, I think there are to my mind, two interesting kind of techniques that be pursued here. This kind of 3D printing calcification process itself, and then there's the cycle GANs. Well, I mean, cycle GANs, I mean, you're talking about feature extraction. I mean, that's all it is, a two-dimensional feature extraction from a pattern. We're not in any way dealing with three-dimensional thing, and you can only get three-dimensional by incorporating other strategies, techniques like PyTorch 3D is the one that's been explored, but we're still at a very primitive stage in that. So, I mean, it's not, I mean, don't overestimate the intelligence here. It's really not that intelligent. It's just simply picking up features on a two-dimensional plane. And I think it's not a high level of intelligence anyway. So what you get with the cycle GANs is simply two unpaired data sets, which they're kind of interpolating between the two, and you're just getting a two-dimensional pattern. It's not a meaningful pattern in many ways. It might be interesting visually, but it's not meaningful. But there is a kind of material, I would say material intelligence, but intelligent use of materials that could be detected in the way this process of printing. And that's the thing that really fascinates me in some ways, is that so what, you know, what can you do with this thing? I mean, do you have to leave the wires in there? What are the kind of the growth patterns that could be grown from it? You know, what is what is the depth of the incrustation you can get on the either side of the wires before the electric charge has no capacity to kind of go any further? So, I mean, that's actually the thing that I find really interesting. I mean, it's just that the cycle GAN is just pattern making in a way, and it's beautiful project, yes, in a poetic sort of way. But there's a kind of like the Manuel de Lander-esque kind of material philosopher in me wants to find out more about this process of using this novel printing process, and I suspect that it works well in terms of kind of calcifying existing metal objects under the water. But I'm not sure how well it would be good. How good it would be at kind of generating something. I mean, it seems to me you have to leave the scaffolding in place, and I would be interested in what the scaffolding would be and why it is what it is. So anyway, that's maybe that's not the aim of the project, but I guess let me just finish with one comment. I mean, with when I was working with Barojos Neves, who developed the whole kind of contragraphing thing, he made this comment one. We were driving somewhere in LA, and we were looking at these huge kind of billboards that you have above the road, and enormous things, like huge bits of metal, and then there's a kind of an advertising hoarding of some kind. And he said, what's interesting about that is not the billboard. I mean, everyone's looking at the picture. I'm interested in the structure itself and the cracks in the structure and the performance of the structure and so on. And to my mind, this project's more about the billboard, right? And I'm really interested in interrogating, which is a different project, let's say a different project, but I'd be really interested in the process that the electrolysis or whatever you call it of generating these reefs. I think it's got real potential, but there's a logic there that could be pursued further. Anyway, sorry, that's enough.
I mean, I think that the kind of interesting aspects of the cycle gun here for me was precisely that he kind of tried to use it as a sort of extension of this material computation process that occurs in the biorock. So in a sense, the kind of patterns and cracks and concentrations on minerals and nuances that develop in these samples of him are kind of picked up and sort of transferred into this other scale, where obviously may engender a completely different set of relationships and processes, but still are kind of connected through this element of pattern recognition. That is what the cycle gun does, as you said correctly.
But it's just feature extraction. It's just looking for things you can see in the image and which you can translate. It's not really intelligence at a kind of mineral level or a kind of material level. But I mean, this is actually a huge project to do. I mean, it's actually you could do a PhD on the mineralization process. You could do a PhD on the kind of the cycle GANs process and so on. So it's kind of ambitious, and I don't want to sort of kind of critique it. And I just simply say that actually, to my mind, the interesting thing is the mineralization process, and I don't know how you would develop a logic for this. But anyway,
but he's young, no? He can do a
Yes,
few PhDs one after the other. I mean,
I agree with everything that was said, and I mean, we're fascinated, right, by your project, and I think it's again, it's kind of like how you structure your presentation led us in one way, but we're kind of trying to focus in the beginning of the experimentation and this kind of to understand this material and the possibility, right? I mean, to channel Louis Kahn, what does biorock want to be, right? I mean, kind of like we want to understand what is possible, what are these structures, and I think if you kind of add that to your story, it will be a much richer project in the presentation, and then years of more research, of course. But for now, you can do that.
I can conclude, Miro. Remember, like 1 year ago, we were saying that there is a large water tank that we bought with Claudia in the lab on the ground floor. So, and I was telling you, Miro, that's your water tank. You should use it, and let's build a large structure. That's what should be done now. Let's start your PhD, and this tank is still yours.
Yeah.
Oh, well, I like the controversy that unexpectedly the project has been triggered. So thanks for the comment. Shall we move on to Dominique?
Just can I say one more thing? I think the real potential is not as a finished product, but as ongoing project of purifying the water, aggregating this coral. And I see it as not as like here it is, but actually over a long period of time, the potential of this thing building up of the process.
Yeah. Well, that is, of course, I mean, no one of the projects we deal with usually are finished, because of the time we deal with elements that grow. And so growth is intended as something that change all the time. In fact, one of the things we often say is, we need to work with climate change, but we live in a planet that is continuously changing. So the question is how you understand change, draw it, and evolve it. So in that sense, I think, yes, definitely the project in a way envision a infrastructure that is almost an interface of how different elements could grow. And I agree also with Eduardo, it would have been probably interesting to expand on the element that could come out of this growth in terms of other unconventional use of the biorock, like growing architectural component, growing element that could become part of our local economy, that could also be
your marble
and pollution marble. So yeah, that is of course one of the interesting aspects and one of the traditional aspects the lab works with. On the machine learning, of course, is not about having the super intelligent algorithm, but again, we treat it similar to what we treat many of the intelligence we work with that are not complex intelligence. For example, we have a lot of work done on Fusarium polycephalus, slime mold, but they provide, while interconnected with other systems, a form of correlation between pattern language at other level of intelligence, not taken by themselves, but in correlation with other systems, which I think also is what the project has been attempting to do, and the way we are attempting to use in this technique. Not conceiving them as a high form of intelligence, but rather as something that can interface with other intelligence and create a more complex ecology in that sense. But yeah, thank you, Miro, for the presentation. And yeah, let's move to Dominique. Thank you.
Yeah. Thank you, everyone, for your comments.
Thank you, Miro.
Thank you, Miro.
Okay.
Well, maybe project and thesis that are like so speculative or research driven, they could in fact conclude the presentation like Neil was suggesting, with a series of lines of inquiries that the candidate feels are obviously not completely explored, or maybe even just touched upon, but that he feels are interesting to him or her, and could lead to further research. Also as a way of kind of not necessarily concluding the narrative with the idea that everything is perfect and works and is resolved, but rather that this is really a kind of first step moving from undergraduate to postgraduate or to other level of research.
Yeah, that is also an interesting tendency. We're doing a diagram about the different level of courses in the lab, and there was an idea that while we move towards the master thesis and the PhD, we go more toward design innovation and that type of research, and how it gets applied into architectural urban systems. So that could be something to integrate in the thesis as a speculation of how it could be brought further.
Okay. Hello, everyone. Can I start?
Yes, please start. Otherwise, we don't stop commenting. So just go.
Okay. Good evening, everyone. My name is Dominik Wagner, and I am going to present you my master thesis with the title Bioport, Landscape of Mobility. Bioport is a design proposal for a transport typology based on the production of microalgae for a photosynthetic airport architecture. The current COVID-19 pandemic poses to be the ultimate test for many airlines. The phase of economic reconstruction could be a chance for aviation industry to pursue new strategies to address current issues such as sustainability and social responsibility, to focus on research of electric autonomous and modular sharing systems in the combination with smart rail and ground operators are as important as sustainable aviation fuel strategies. Cultivation of microalgae could be a highly potential solution, as it is possible with it to produce rapidly renewable, energy-rich biomass through photosynthesis that can be transformed to biofuel for present and new transport technologies. Urban development around Lisbon's airport Bordella makes an urgently needed expansion impossible. That's why a military airbase on Montijo Peninsula, southeast of Lisbon, was finally chosen as a site. It is surrounded by wetlands that are going to move constantly inland as a matter of sea level rise. In order to generate digital terrain informations from the military airbase, a height profile map was used to create a 3D model of the existing site in two strategies. In strategy number 1, a future eroded terrain was simulated by multiple digital erosion processes. A possible sea level rise shows the areas that could be flooded in the future. Therefore, in strategy number 2, the 3D model was again vertically modified at the areas that will be flooded in the future and digitally eroded in several steps. This creates a digital artificial landscape that shows a new second surface. This surface represents a fusion between the future original terrain and a digitally generated artificial landscape. It will represent the roof area of the airport building, but also provides topology informations about the original site. This comparison is showing the two strategies without sea level rise, and this one with sea level rise taken in account. In order to get a better understanding of the topology of the generated landscape, the contour lines and the flow lines were made visible. With the help of value analysis, a new possible spatial planning master plan can be read off, which corresponds to the natural topology of the terrain. It was made visible with an urban public space plan and a figure ground plan. In the next step, two possible scenarios are to illustrate the digital generated landscape and to get an impression of the transformation. A picture translator called CycleGun was used for that. For version number 1, a satellite image is chosen that shows the rural character of the Montijo area through a machine learning digital process. This image is translated on the synthetic landscape. For version 2, a satellite image of the historic center of Lisbon is chosen in order to achieve an urban character. The synthetic landscape surface is generating the airport structure. The Bioport acts as an interface between land, water, and air. Infrastructures and mobilities are brought together.
Is there somebody that has got a microphone on? Can you please close it? Because we hear a noise.
Is it? Claudia, I think you can mute. I see that Peter is on.
Okay, yeah.
Claudia, I think you have enough permission to mute everybody.
You can continue.
The Bioport as a building. On the west side, the building borders the Tagus River and is therefore open for shipping. On the east side, the building is delimited by the existing military runway. New parking lots and taxiways are added. In the area of the former east-west runway, the connection to the railway network will be ensured and a new run field for short-range aircrafts provided. The topography of the roof makes the cell structure visible in form of landing zones that are part of a pocket port network. They are intended for vertical takeoff and landing aircrafts. In a sustainable post-COVID scenario, the focus of the transport of people and goods should be placed on flexible regional systems rather than on intercontinental ones. A new additive mobility layer is being created by urban air mobility and is represented by urban pocket ports. To provide a system like that, the Greater Lisbon map was analyzed. Strategically important locations, such as existing airports, train and subway end terminals, important city town centers and tourist destinations were marked, which are to be provided with these urban pocket ports. Since these points are mostly centrally located and should be left as quickly within the shortest path due to noise nuisance, each of these points is assigned to a flight circle corridor that adapts to the local conditions. As a result, flight corridors appear which are representing 3D highways for urban air mobility. The roof as a bioreactor. By using curvature modifiers, the roof shape is divided into concave and convex zones, which can be read through valleys and ridges. The valley arms are forming the main structure of the building. The circulation of humans and machines is ensured under these zones. The ridges zones form the translucent part that flood the interior of the airport building with light. Here also landing zones for smaller unmanned aerial vehicles are being created at certain points. The roof takes over part of the energy production in form of biomass production and photovoltaics. A flexible and constantly changing pipe system runs over the entire roof. It has the ability to move over the surface and adapt to the external conditions. It is following the path of the flow lines as a matter of gravity. As a result, the building becomes a kind of dynamic photosynthetic organism with the help of artificial intelligence. To cultivate microalgae in a closed pipe system, a system principle was followed that occurs in numerous forms of natural biological systems, such as in neuron growth, pollen tube lengthening, and the cell structure of plants. By adding water and air pressure to a rolled up synthetic translucent synthetic hose, a self-contained system is created which should maximize the cultivation of microalgae. This system, by inverting its own material, can achieve a substantial controllable change in the length from the tip by recreating its structure along its growth path. This leads to the ability to move through restricted environments without sliding friction. As the tip moves, the body forms in a structure in the shape of the tip's path. In addition to its function as a photobioreactor, this system also has the ability to convey data, energy, or material through its soft inner film. The static structure. On the end of these flow lines, the soft robot tubes are combined into bundles and led over the static support structure into the Bioport refinery that is in the core of the airport building. There, the oil is extracted from the algae by breaking down their cell structure. After the oil is extracted, it is further physically and chemically processed to raw gasoline. The bio-oil refinery on the ground floor will make the process of fuel production visible to the airport user and explain the individual process steps. Thus, a relationship with the locomotion energy source is established by the traveler. The photosynthetic robots are not only operating on the roof structure, but are also expanding on the water surface of the Tagus River, making use of the otherwise unused wetlands. Their controllability allows the flexible robots to maneuver into water zones that are ideal for the growth process. Bioport is a new definition of landscape that integrates and redescribes the functions of infrastructure within its logics. Machine learning processes and digital simulations are creating a new language of architecture. The project breaks down long-established rigid aviation systems by making visible a new layer of mobility in form of new technologies. A new social shift of principle, away from nowadays extreme mass consumption served up by low-cost airlines. Towards a new sustainable, ecological and regional layer of air travel, with the powerful help of artificial and biological intelligence in a digital age. Thank you very much for your attention. This was my presentation.
Thank you. Thank you,
Thank you,
Dominic.
Dominic.
I thought it's very impressive, very ambitious. No, because you work with very different scales. You work on a scale that is regional, on really large scale, developing some urban strategies, exploring the landscape, exploring how the landscape can help you in order to organize functions around it. But then you go down all the way to the detail, and even if through your images, your images, they have a kind of the when you go inside under that roof, and when we see what happens to the space, I think it's, of course, it's very provocative. There is a kind of huge, like, kind of fictional aspect to it. No, I think it's maybe hard to imagine that that this is something that belongs to our world of today, but because it has this such strong image. But I think that when we listen to the narrative that you provide, and when we understand the fact that this roof is performative, that this roof harvests energy, that this roof produces biofuel, then I think it's really easy to follow you into that fiction, and to understand that maybe you are not as crazy as the image suggests, no, and that and that there is a kind of strong rationale behind the project. I really enjoy this idea of the offsetted landscape, of this second surface that is inhabited, not only from underneath but also from above. I think that there's a huge poetry in there about how it relates to landscape, but also to landscape design, our habitation of nature, our understanding of the natural environment that is also partially domesticated. I think that this is very strong. Maybe for me, what's maybe more questionable, I mean, I don't know if it's questionable, but if you talk about a kind of self-sufficient way of dealing with the landscape and with the inhabitation of the landscape, then the question of the airport, of course, is tough, no? And I can imagine that this is something that you also sometimes struggle with, in the sense that there's many people that argue for airports being or air travel, especially if you're Swedish, being the enemy somehow. And I mean, I understand that you're dealing with that in the sense that you're providing biofuel for it. I'm wondering whether what the numbers would look like, no? And I think I would be tempted to kind of push you to follow the project into maybe a much more kind of a living style or yeah, a way of living that actually necessitates much less energy, because I think that maybe then the project can really become autosufficient, and then this kind of symbiosis that you do with the landscape could really operate. But yes, I think it was a very good presentation, and a lot of stuff you've been doing, very seductive. So very happy to listen to you.
Thank you very much.
I just want to kind of understand your process and kind of the connection between where you started, where we talked about the topology of this generated landscape, all the way to the building on this slide. And then what I imagined was that you could, if you had a way to manipulate the landscape, then is this building like now underground, that it's then carved within this landscape? Is that your process that you described to us?
Yeah, so
Or
yeah.
it's just man-made to look like the landscape? That I'm trying to understand that.
So that the created surface is a kind of symbiosis between the natural terrain and added artificial parts to the landscape. And so it is, yeah, the process followed the steps that I started from a very big scale and tried to go always more inside of this terrain, and used always the same parameters or changed them and tried to come from a bigger scale into the smallest scale.
But is this building then carved into the terrain, or it's constructed from scratch? Is this the terrain and you carve the building into the terrain?
It is built on the terrain, yes.
Okay.
But it's not carved, from what I understand, no? It's an added surface on top.
It's an added surface, yes. But the added surface interacts with the original ground.
So the added surface follows the contours of the original terrain.
Yeah.
Okay. And then why is that?
Yeah, that's it was a design process that I followed, and so in the end it comes to that solution. I hope I can answer it with that. Sorry.
I just want to understand your process. I mean, again, it's such a rich project, and it has so many different parts to it. And I obviously the algae part, it's I mean, clear in a way that we understand the process has to happen on a massive scale, and there are a lot of questions with the scalability, but that's clear. But I'm just really interested in your process of generating this, you know, a new type of airport building. And to me, it's kind of much more interesting if that was actually happening, if the terrain that you manipulate to then feed all the different functions of the airport, but the building, it's actually under the terrain, and it's kind of leaves that undisturbed terrain. At least that's what I imagined listening to you. So that's why I'm asking you all these questions.
Dominique, maybe you want to explain a little bit more how it relates to the landscape and also the aspect of connecting to the water. So not only to the landscape as soil and existing solid landscape, but also to the water landscape, because that's how you have been conceiving this in response to Maria's question.
The water landscape.
Yeah, the wetland.
The wetland. Yeah. So the wetlands I'm using to grow the soft robots to expand this system I invented, to use these flat areas in the water that is not used for nothing right now. So because the sea level is rising and the area in this bay is getting bigger and bigger, and so in this case you can gain more positive things out of this actually negative scenario.
Because I mean, Dominic, actually, maybe for me, what is interesting here is that what you called these soft robot and algae farming devices. I mean, in the end of the day, they are really about creating a new sort of aquatic landscape. Because I mean, everything that you describe here happens in water, within water, or in relationship to water, right? And you know, even your interior image that, you know, I don't know if you can go back to it. I think it's quite intriguing. It's essentially it shows this kind of wet interior almost, right, with fountains and so on, which kind of in a way reminds me a little bit the you know, the Singapore mall / airport with this sort of gigantic waterfall in the middle. But you know, somehow here, of course, is built into a completely different logics of, you know, the waterfall becoming essentially, you know, part of your biofuel production system, right? So again, I think this image, it's in my mind, it's really the key, because somehow kind of attempts to synthesize, you know, these really intriguing, I think, thesis of yours, which is that essentially an airport can become as much a place of, let's say, interconnectivity and perhaps even leisure, as well as about a biofuel refinery, if you want, right? To fuel, to power the aircrafts in a sustainable way, in a renewable way. And so I think that's where I think the project is, you know, quite sophisticated, because it's the first time that I see this level of, let's say, integration being explored from the point of view of the technology and the system, but also from the tectonic and architectural point of view, and taken to such extreme conclusions in a way to begin to really reveal another kind of world that may be brought forward. And you know, again, this environment may well be kind of underground, like Maria is suggesting, this image, and maybe lights could only penetrate through these holes, you know, in between the kind of cascading elements of algae. You know, I don't know. You know, obviously this is open to interpretation, but in that sense, I think it's where the project for me it's really successful, because I've seen a lot of projects trying to engage with this topic, and they either go into the completely fantastical or in the completely reductionist technological. I think this is the first time I see a project that achieves in a way a credible synthesis of these two levels, and really kind of convincingly proposes a vision where you know, a sort of technological overhaul of the industry, if you want, can actually generate real architectural and landscape innovation or invention, which may again benefit the whole region. I think that another really interesting point for me was the way you kind of build this into the region from the point of view of the landscape as well as the mobility itself. Again, no? So perhaps shifting the attention to different kind of mobilities, reducing maybe long haul and you know, reinforcing these kind of network, these distributed networks that somehow the landscape suggests, but that they can also become very much a new sort of infrastructure of mobility across the region.
Marco, when you speak, it makes me feel that we need to have a debate on the real color of algae. Because when I look at the algae behind you and the algae here on the screen, I'm wondering which one is the most accurate.
Well, I think this is a spirulina, yes, the other one is chlorella.
Yeah, one is chlorella. No, actually, Marco, you have chlorella. This is spirulina.
I have chlorella. This is spirulina.
Spirulina is green-blue. I can show you. 1 second. Hold on, everybody. Yeah, that's it. Spirulina. We don't have chlorella. It's not in season, sorry, but it's more yellow-green. But there are also red algae and like porphyridium, blue algae, and multiple color. That actually would have been nice to expand on it. And they respond to different. Actually, this is a good point, because if the project cultivates algae for the whole year, then it would change color during the year, because algae are seasonal. And the spirulina, although Portugal is quite warm, the spirulina that you will see here would be most appropriate in summer, but in winter you will switch to chlorella or other breed of microalgae that have slightly different color. Actually, good point. Like a joke, but it's a good point.
But I mean, I wanted to go back to this kind of also looking at this, the interior, it also kind of has this cavernous quality to it, and I mean, really beautiful, kind of like imagining this kind of a new type of algae forest that you have created here. And the thing is, though, with I mean, with the light that you need and kind of the ability to provide you know, artificial light in such a, you know, how should I say, efficient and energy minimal waste these days, as I can imagine that this growth can happen now underground. You don't have to, you know, rely on natural light, and that can intensify the cycle. And so I can really like that kind of story of the robots and then kind of this, you know, algae kind of trees and forest, and then kind of being exposed to the whole process, if you will, of how you collect it. And you know, I mean, I wasn't involved with creating the project, but I've visited it there many times, the BIQ building that Arab did in Hamburg, and I mean, it's quite beautiful to kind of experience these spaces and live with, in that case, the algae walls, and then you know, and then you go in the basement and just a regular boiler, they have, you know, the ability to concentrate it, centrifuge, and then I mean, and then eventually turn it into a biofuel. Still experimenting, still, you know, a lot of questions about the scalability and efficiency, but we're getting closer. So I think this is just kind of a really great idea to bring it to an airport. But I think it's again, kind of the narrative is kind of that needs to tie your project together, where you started with the landscape, the water, and then bringing us inside. There's kind of I'm looking for a single thread, the way you tell that story. That's kind of, I felt a little bit lost, but I think, you know, it's a very rich exploration and really convincing, I have to say. I can imagine this type of airport, and I haven't thought about it before, so congratulations.
Thank you very much.
Yeah, Dominic, thank you very much for the presentation. I'm also very happy to finish at this point. I'm very happy with all the development. I really love your drawings, and I think the final images also went really nicely, really convincing. I absolutely agree with all the comments, and thank you everybody for commenting. Yeah, and actually this really makes me think about the future of our, I don't know, travel, of I don't know, do we really keep the transportation as we have now? Do we stay in the place? Are we nomads? Are we locals? What do we do? I think I questioned this to myself, and I don't know, your project brings this thought as well. So I don't know if we don't have any comments, Father.
Yeah, I think, yeah, definitely making traveling or this type of traveling more eventful and related to other type of activities such as, you know, biotechnological farming. I think it's a relevant topic to discuss. It would be nice, I think, of course, the project also tap in some of the research that the lab and the team has been doing for a long time, and that is good. It will be nice, I think, if you bring forward the research to develop also more material experimentation. This is something that traditionally we do. We took another direction for people, which I think was successful, but in a way to explore these nuances of what would effectively happen in different season or in different moment when we have temperature, microclimate, tidal that change, and so the harvesting of microalgae induce changes of color, but also changes in performance of their building and interaction of the user. I think this would be an interesting aspect to explore further, both materially than in terms of design.
Mm-hmm. Could I just maybe add something? I mean, I prefer not to comment on this project because it's very kind of like enigmatic, and I'm still trying to understand it in some ways. But I mean, I'm probably I think, along with Mark Burry, the kind of, I certainly used to be the worst culprit in terms of kind of traveling, right? I mean, I used to commute every week from West Coast to East Coast, from LA to Miami, and if I wasn't doing that commute, I would commute to Shanghai. I mean, and then I would go back to England for Christmas or for the summer or something like that, whatever. You know, I'm the worst. And actually, I quite enjoy not traveling at all. I mean, Mark Burry is the same. He was based in Australia. He was working in Barcelona. And he said, I don't know why I was traveling so much in the past anyway. So there's a kind of inherent sort of dilemma anyway about the whole thing about having an airport and the green ecology sort of thing. And it's actually quite tricky to know where to pitch this project in terms of in terms of whether it's being pragmatic or whether it's being completely poetic. And it's kind of an interesting kind of mix of both. And I don't know, it was kind of going, it's, you know, I think it's a little difficult to put your finger on exactly what it is. That's why I'm hesitant to say too much. I mean, it looks beautiful. Of course, it looks beautiful, you know, but I kind of think that, you know, having spent so much time in airports, probably what's going to happen is that it's going to be ruined by something, you know, signage or something, or people selling coffee or whatever. You know, it's the purity of the kind of vision of somewhere like Stansted or something is always destroyed by something that goes in there. But you know, I want to just kind of end the kind of the way that that, I mean, just in general terms, that this studio, in the sense that I think it's really important to see architecture as being a kind of as alive. I mean, there are two things. There's a kind of biological kind of emphasis going on here, but also the kind of the idea of sort of keeping architecture alive as a discourse. And I think the idea of trying to bring in these new technologies and techniques to open up and keep it dynamic and not to fall back on these kind of old historicizing things is there. I mean, the one challenge you're going to have is if an engineer comes into the studio and says, well, you know, how do these structures work and how these things, but never mind. I mean, I think it's a kind of strategic kind of awareness opening. But I would just want to say one final thing, and that is to say that, you know, I'm on Venice Beach, right? And there was a street called Ocean Park that they made. There's a new green street, right? Which I don't know whether you can get a green street for with cars anyway, whatever. But and at some point, you know, we were putting these trees in and things and whatever, and then they they painted it green. No, literally painted it green. And you thought, okay, right, okay. So, but I'm not criticizing that. I just think it kind of goes hand in hand with it. And I think it's important to kind of like be aware of all these things. But, I just want to commend both projects. I mean, I think I was kind of taking the first one too literally because I was fascinated by the 3D printing project. But both of them for kind of just trying to sort of, open up this kind of field of inquiry to interrogate sort of things in a new way. And you know what, just because Claudia said we met at the AA, and when I look back on that, I look back at some of the figures who have emerged from that time at the AA. I mean, whether it's educators like Ciro Nachri, who's gone on to become a really interesting figure in his own right, or then students like Neri Oxman and Aki Menges, they were actually students at some point. I think it's important to sort of to keep this inquiry going, because I think nothing comes. You need to kind of keep an open mind and keep kind of interrogating things in order to improve architectural discourse. So So I want to thank Claudia for allowing me to sit in on this, which has been a fascinating experience. And I think there's actually another meta debate to go on beyond the sort of the critique itself about this whole thing. So I've appreciated it. And I'm sorry if I was being too tough on the first one, but I was actually fascinated by the first project in many ways. But it's in this very beautiful, enigmatic kind of comment territory. And in some ways, actually, I'm kind of reminded of Ciro here, because Ciro would always bring an engineer in, and usually it was Hanif Kara, and yet I mistakenly, because at the time we produced a book called Digital Tectonics and a conference about that, and I mistakenly thought that Ciro was interested in structure. He said, no, I'm not interested in structure at all. I want to get beyond structure in some way. And there's something here happening at multiple sort of levels in terms of the kind of the discourse that's happening, which is fascinating and elusive and curious. And I think it's I've got to say, I think that what's happening also in any case in Innsbruck is kind of interesting. Somehow things that were happening elsewhere at Angewandte are now happening in Innsbruck, and it's great to see that kind of dynamism happening and how you can keep the debate alive. So it's really about keeping the debate alive more than bio as such, but I think it's fantastic work. So congratulations.
Thanks. Definitely, Ciro is always in the room sometimes. He was my tutor, for the record. So mine and Marco's tutor. So, and in a way, as he will say, we are not interested in structure. I'm interested in to go beyond the structure. Here, we are not necessarily interested in ecology. We are interested to go, or in sustainability. We are interested to go beyond. On the question of the comment on the project instead, I think in terms of mileage, Maria and myself tend to compete pretty well. We used to compete pretty well. And somehow I do agree with your comment, but the way I saw the project is maybe slightly different from how Dominic posits, although is inherent in the project itself, because the way I see it is that the site had all the quality to become an area where a microalgae could be cultivated and integrated in what was the designated program for the site, which is an airport. But maybe occasionally the airport could become something else. Occasionally is an airport, is a transport hub, but not only for human. There are these drones that at the moment cultivate, but maybe they are also transporting goods. That is something that we use all the time. And people, encounter there, and encounter is a little bit, let's say, rethink what the airport had become in the latest period. As you mentioned, Stansted, and I think is not a chance. I mean, although maybe Norman Foster is not exactly the way using the same methodology they apply, Stansted, I think, was a beautiful airport, until lately it was impossible to see Stansted. You will just see sign, right? And that was overactive, overpopulated, both spatially, that in terms of activity. So what happened next? If the whole situation doesn't disappear, but maybe go back to being, a space where you can interact with multiple elements, and you could have a sort of pleasure that allow you to connect with your traveling, but also with the production that could happen on the site, because the site has got these characteristics. So in a way, maybe in my level of understanding of the programmatic occupation of the site, the airport had a much slower pace to the airport we were imagining before the pandemic. And the question of production and creation of productive public space probably at a higher level in the sense, which is an aspect that will be good to speculate further to see what would happen next to this typology.
Yeah, I mean, just to say also, I think I don't think many people have really taken this kind of the question of the impact of the pandemic, I think, far enough, because to my mind, architecture is the kind of exoskeleton of a kind of lifestyle operation that is actually not going to happen anymore. I mean, or at least it'd be fundamentally changed. And I actually think that, and just to kind of take it sort of further, I think part of the role of the architect is to imagine not just buildings, but kind of systems and maybe even operations, that happen. I mean, that's the way I see myself as an architect now, as an architect of educational systems, trying to set up platforms for debates where this is part of it in some way. The fact that I'm in LA and you're in London and Innsbruck and St. Petersburg, to try and imagine the possibilities afforded by that. And I think really, in some senses, that's almost the next step, is to really, for us as architects, to get our head around not just buildings, but actually structures of operation and using our architectural imagination to think through this in some way. But that's another question. But,
no, that's definitely the point, because also the architectural response, the current architectural response to the pandemic is definitely outdated. No, is the one they gave in the last century. And, virus, bacteria are systemic organisms, they don't stop on a door, right? So what is, if, this ecological system will keep, explode and creating conflict, then how do we deal with that? Definitely we should deal with that by engaging with systems that are both system of communication, like the one you are, and creation of culture, that system of production and interaction, different type of interaction with the biological system that populate the planet as well, which is something that primarily this project is proposing, in my opinion, and as well integrating with other programmatic elements of the city. That part probably could be pushed a little bit forward, but definitely is not about simply thinking about space, but it's primarily thinking about system that have a material counterpart.
I think the material counterpart is the important thing, because in some ways, we've become very dematerialized in our present existence, but that actually heightens the importance of the material, just as the fact that we've become decontextualized in some sense. We could be working anywhere. That means that place is really important. And I think there's a lot of really interesting architectural sort of questions that have been thrown up on the horizon about how we understand the material occupation of space in this new paradigm. It's fundamentally different. Anyway, but that's a long story there. But I just wanted to thank you, Claudia. I was inspired by the work and the provocation of this thing. And it's to my mind, it's less about biology per se than keeping architecture alive as such. So it's been great work. Thank you.
Thank you for the comment. So thank you, Maria, Neil, Ed, Marco, and of course the other Maria. And to the student, are there any final remarks on both presentation maybe, or on the day? Neil already made one, somebody else?
I mean, I just wanted to say, very impressed with the really high quality of both thought and experimentation and development, and then the final presentation. I love the video. And I think it's really, I mean, it adds a lot to the discourse, I think, of the architecture and the built environment today. So, and I've learned a lot. So thank you.
Thank you.
For the invitation and for having me.
Thanks.
I'm also very happy to have been here. On the project, I think I enjoyed a lot in the second project the kind of risk taking of going across scales, because I think that there is definitely a kind of feedback in between a large infrastructural space scale, but then also the one of inhabitation. And of course, it's very risky, and there is as many questions, or there is maybe more questions that come as answers, no, on many pragmatic levels. But I think that it ties the story very well, and for me in the first project it was difficult because we stayed very zoomed out, and I was struggling to understand eventually where was the human back in there, no, and it's not. I think in this sort of approach, it doesn't need to tie back to human inhabitation necessarily, but I think the question of the small scale remains. So I like that in the second project, to be able to jump from one to the other, because the small scale questions the large one, and vice versa. And I think it also opens a huge kind of imaginary world, no? That is not an imaginary world, but a kind of imaginary dimension to the conversation, which I think is important and very productive. But yes, I liked it. I enjoyed it a lot. Thank you for the invitation, Claudia, Maria, and everyone else.
Well, I was lucky enough to see the projects during the green light, so not long ago, as a part of the external examination. And again, I remember giving some comment and feedback at the time, and in what is like 1 month, or not much more than that, again the project made another huge step. So again, this is really something that I think you deserve a lot of credit for, because again, it's also not an easy condition to work. There is, you in the end you're working, in isolation for a long time, and we obviously try to give feedback, and especially your tutor, etc. But you eventually did it. So I think this is huge credit to you for this, and congratulations, I think, for both projects. And again, for having now seen a few thesis projects over the last couple of years, I think there is also really exciting development in terms of the overall format and of the thesis project in the lab. And again, I think this is really something that is worth moving forward. Take care of it and develop further. I think there is a lot of potential. Again, what Neil was underlining, the value of education and research is evolving. And I think from the perspective of the students, it's the same. I mean, I didn't think thesis projects are no longer just a last bit of work before we finally leave university. I think it's becoming really the possibility for you to create your own platform, to interact with the world, to contribute to a conversation that goes way beyond the little studio or even the university you're part of. And so in that sense, really for me, the kind of element of research that are embedded in it, and that you haven't, of course, resolved fully, but that you have touched upon, and you have developed already your own little bit of expertise in that, which may be embryonic, but it's very, very personal to you. I think that's where you can now take it to another stage, and begin the next step of your career, whether these are going to be in a sort of PhD academic format, or whether it's going to be in the practice, or whether you're going to be able to connect the two, which is I think a great chance you have. I think this is really what this new thesis format can provide, and I think that's really worth continue the evolution of this in the next few months. And then again, thank you for having me, and so it was a pleasure to see also Eduard, Neil, and Maria after quite a while. And I still hope to meet you in person soon, despite the fact that I also not necessarily miss hanging out in airports for as often as we used to. But I think I kind of now miss quite a bit some sort of post-jury drink or dinner and so on.
Something about the drink, definitely.
Well, and I mean, I personally am ready to travel again. Marco and I saw each other last time we were in Kazakhstan, right?
That was quite a dinner, for example, right?
That about painted grass. I remember before of the opening in Astana, the grass was not growing enough, and because the president
sprayed. That's beautiful.
The grass.
Anyway,
White greening.
That's a Miami technique.
Yes.
Technique is sportive in Kazakhstan.
Maybe, can I just say something to Miro and Dominic? You're about to go out there, right, into the world. This is your last student project, unless you do a PhD or something. And I know one thing I would say is that just from observation, going back to things, the most important design you're going to do is to design your own career. And I think what you should know is that the world of AI is out there, and it'll, by the time you reach the peak of the career, it'll really be part of it. So you've got to get wise up to that and be part of that. And it sounds patronizing advice, right? But I think say that all the people that I really admire in architectural culture, and that includes Claudia, didn't copy anyone. They didn't go the mainstream. They reinvented something in some way, and that goes to Zaha, Rem, or whatever, or Neri, or Akim, and so on and so on. So, this is a chance to do something, and that's the real thing is how do you design your future? And it's a very interesting question because of COVID, because of AI, everything's upside down. It's a new world out there, and at least you are aware of some of those questions right now. So take it on board and do something interesting. Yeah.
Thank you very much.
Okay, thank you. We of course agree with the last comment. We will discuss that in our next meeting. But congratulations for now on this last year of thesis. That is challenges, but also incredibly enriching conversation in the conclusion. So I think that was great. We'll be in contact with the student and also with the guest, which I guess we will see again online soon and sometimes in person as well. We'll figure it out.
I just wanted to say, I want to put a plug in there, but is there available? We've got a thing on AI and creativity on Saturday on Digital Futures.
Go for it.
With Refik Anadol and all those guys from SciArc are going crazy, which is not so much about whether AI is creative, but what creative possibilities are afforded by AI. And if you want to go on the Sunday as well, there's something about neuroscience and AI. It's really a hot topic now. So you're lucky that you've been introduced to it. I think it's the name of the game from now on. So yeah.
They know it all already, at least our student. I mean, the events. Me and Maria communication. Okay, thanks a lot for seeing you. See you again soon. And Neil mentioned the Digital Future Network is a great event. Just join them. Me and Maria will, all our team will also
I'll be there.
Discussing things. So see you.
Also the Russian one in 2 weeks' time, right? Maria's part of a Russian, some crazy Russian artists.
We have the two of these in the PhD course as well.
Yeah, so thank you very much, everybody, for great conversation. And guys, thank you for the projects and presentations. Congrats. That was great to see everybody.
Ciao, ciao. Bye-bye.
See you soon. See you soon, everyone.